Well, hello everybody. This is Alexander Prokhorov speaking. I'm a head of software development here in Data Advance. And there is also our marketing director, Maria. She will assist me during the session. If you have any questions, then please use chat for feedback during the session. And Maria will process it and let me know if there is something that I need to comment on. And we will have a questionnaire session at the end. Okay. Today's session will consist of a presentation. I will show some slides. And then there will be a demonstration, live demonstration of pSeven. If something goes wrong, please accept my apologies in advance. As they say, the first rule of live demo, never do live demo. Anyway, let's start. Well, how will we proceed? I will start with a brief description of our company and our product line. Then I will focus on the new features of pSeven 6.6. And the main feature, of course, is a Predictive Modeling Toolkit, which significantly simplifies work with surrogate models and provide everything needed to build the best possible surrogate models. So I will briefly go through other important updates and finish with live demonstration of Predictive Modeling Toolkit to show you this toolkit in action. On the screen you can see the sources of all the information I will tell you today, I will show you today. It's changelogs and release notes. They are always available on our website, and links, you can see the links on the slide. You'll get the slides after the session, of course. Well, let me start with a brief introduction of our company and our product line. Actually, I assume that most of you are familiar with Data Advance, so I just quickly remind the main points. Our product line contains two software solutions, pSeven Core and pSeven Platform. pSeven Core is a library with Python interface which contains data mining and apps. Its main advantage is advanced and efficient mathematical algorithms accompanied with smart selection technology, which automatically selects the best method for users' problem. Previously, this mathematical library was named Macros, and now it's going to be renamed to pSeven Core. So pSeven Core is nothing else than good old Macros library. Anyway, this webinar is not about the pSeven Core. The product I will focus on today is pSeven Platform. pSeven Platform is a design space exploration platform for every expertise. It provides high level of process integration thanks to sophisticated workflow data flow model and thanks to deeper CAD and simulation software integration. pSeven Platform contains pSeven Core completely and provides all its algorithms in a user-friendly way. pSeven Platform is available in three forms: as a classical desktop application, as a server application which can be deployed on premises, and as a cloud service. All these variants are equal functionally and can be used independently or together. Please note that server version is not publicly available and its release date is yet to be defined. However, beta version of pSeven Cloud is available and anyone can request invitation on our website. The slide on the screen contains a link to the invitation form, and I can assure you that we'll accept such requests quite quickly. Speaking of company, it's also worth mentioning that we provide engineering services and in solution of complex problems. Next two slides are here just to recall main features of our products. I'm pretty sure you're all aware of what I'm going to say in these two slides, but I think it's quite helpful to put all you in the context. Well, what pSeven platform is. pSeven platform is a design space exploration platform for every expertise. Let me explain what we mean under these catchwords. First of all, as already mentioned, pSeven platform provides user-friendly graphical interface for advanced designing and optimization methods, accompanying with smart selection technology. Smart selection makes these methods available for a wide audience of users, not only for R&D experts or mathematicians. Second, pSeven platform has comprehensive and powerful process integration capabilities and workflow engine. pSeven platform allows to create, share, distribute, and run simulation workflows. It provides data management capabilities to collect, manage, and reuse simulation engineering data. With pSeven platform, it's easy to deploy captured knowledge in form of run-ready workflows. Already mentioned, pSeven platform contains full version of pSeven Core, which is formerly known as macros. So it provides all its advanced data analysis and optimization methods, which include, among others, design of experiments, sensitivity and dependency analysis, surrogate modeling, data fusion, dimensionality reduction, design optimization, of course, and uncertainty management. Actually, explaining all these methods is not the point of today's sessions. Today I'm going to focus on the new features of pSeven Platform 6.6. This release introduces the long-awaited functionality to work with surrogate models. We name it Predictive Modeling Toolkit. And today I will show you how to build and compare surrogate models easily with Predictive Modeling Toolkit. But before that, I would like to go through other but still important features of this new release pSeven 6.6. At first, let's speak a little about updates in the algorithmic core. There is a brand new surrogate-based robust optimization algorithm for robust design optimization problems with computationally expensive objective or constrained functions. This method is based on surrogate-based methodology, which is widely believed to be efficient approach to handle computationally expensive problems. This algorithm is automatically enabled by smart selection when there is at least one expensive objective or constraint. And this is important because any more or less real engineering problem typically contains expensive calculations. Well, applying this new surrogate-based robust optimization method allows to solve expensive robust design optimization problems for a reasonably small number of iterations. Another new feature in the optimizer is improved filtering. Now optimization result excludes solutions that are insufficiently close to optimum even if they are satisfy problem constraints. Due to this, the number of points in the optimization result can decrease compared to previous versions, but the result will contain more high-quality points. This improvement simplifies further analysis and makes it easier to make proper design decisions. And one more thing is about block for building approximation models. It now allows to incrementally train existing models with new data. This, in particular, allows to create the workflow which, for example, waits for some data. Once the data is here, it updates existing model with new data, so you always have a model up to date. This approximation block now accepts sample points, weights, and values of input noise, values of noise of outputs. Once provided, such data can make models more accurate. I think that's it about algorithms for today. Now let me tell a few words about updates in integration capabilities of pSeven. First of all, we officially added support for PTC Creo 3. So starting with this version, it can be used in workflows and officially supported. Next, we improved integration with SolidWorks. Now it can be used with, first, it can be now used with SolidWorks 15 and SolidWorks Simulation 15, and there is a proper error handling. This means that situations when, by some reason, SolidWorks was not able to update the geometry of the model, or if SolidWorks simulation could not predict some characteristic, this doesn't necessarily lead to the workflow interruption. Such cases can be handled inside the workflow, so the process will continue. So the process continues. Yes. Next thing to mention here is that we made a more Python modules work out of the box in pSeven platform. It's not secret that pSeven platform delivers with fully functional Python interpreter. And this interpreter is used in the command line and in Python script blocks. Since we know that the power of Python is in its numerous modules, we continuously expand set of available modules delivered with pSeven. For example, well-known NumPy, SciPy, and scikit-learn modules are already available in pSeven out of the box. This time we added more Python modules, including matplotlib, which can be used together with PageViewer in order to prepare custom visualizations. This is especially important for simulation experts who develop custom engineering solutions using our run-ready workflow functionality. And the last thing to note here is that integration with ANSYS Workbench is coming in just a couple of days as a part of ongoing release 6.7. I think that's it about integration for today. And let's proceed. Let's speak about usability and performance improvements in this release. Since the time we sold the first pSeven license, we listened to the feedback from our users very carefully. We analyze all the requests we have in order to improve our product usability and performance. I mean in general sense, not limiting to calculation performance. And in this release there are dozens of such improvements, enhancements and fixes since the previous release. I just wanted to highlight a few of them. First, there were complaints about significant memory consumption during long calculation processes. We have analyzed this problem and solved it. So the case complaints were about now consumes only 6 gigabytes of memory instead of 30 gigabytes which were consumed before in the previous version. And this is significant memory economy, and that's why I'm mentioning it here. Next thing, we slightly improved look and feel of our visualization plots in Analyze screen. We understand that the importance of the post-processing that is what helps to get deeper understanding of the problem in order to make proper design decisions. There were also complaints about that pSeven slows down the number of files in the project increases, and of course I'm speaking about thousands of hundreds, thousands of files. And this issue was resolved as well. Now pSeven performs as fast as the operating system allows it. And there are many more other improvements and fixes. You can see the complete list in the documentation on our website, and there is a link on this slide. One last thing before we proceed to Predictive Modeling Toolkit. In this pSeven Platform 6.6 release, we expanded set of examples available out of the box. We have heard 1,000 times that more example engineers love solving their problems from appropriate examples. And as you can see, we are working in this direction. Let me briefly show you the examples we added in this release. I will switch to pSeven and show these examples. Here it is. To see the list of examples, just click on this examples button in the workspace screen, actually the first screen you see when you run pSeven. And here it is, here's the list. Some of these examples were in previous versions of pSeven. I will focus on ones we added in 6.6. First, we added examples project which named run-ready workflows, and it illustrates how this run-ready workflow functionality can be used in order to prepare custom simulation solutions. Let me show this example in details. I open it, and you see the project description, which contains all the information about this example. There are 4 workflows in this project. First one shows how to perform custom visualization with our page viewer. There is a simple example about ocean ecosystem simulation, just a simple demo. And there are formula parameter fitting, which allows to fit some formula to provided data. And there is also a pendulum parameters estimation for run-ready workflow. I will deeper. I just want to show you how this run-ready workflow can be used. For this, I will open, for example, this or even this formula parameter fitting workflow. To open it, I click here. There is a link in the description, or I can use project list and open this parameter fit workflow from here. Sorry, here it is, yes. And because this is a run-ready workflow, I won't do anything in edit screen. I will go. I'm going directly to the run screen. And here it is. We see the workflow description, which were carefully prepared by the simulation expert who created this run-ready workflow. And there are also some parameters of this workflow. Any parameter has a human-readable description and, of course, some reasonable default value. In this case, I can change, for example, I can provide another, yes, one step backward. I need to say that this workflow solves a generalized parameter fit problem for one-dimensional function. It fits a given analytic expression with parameters to the given sample data. So a user may specify the file where data is like with data, and specify the expression which user would like to fit. Also, there is also possibility to specify bounds for these parameters, A, B, C, D, and so on. And once such workflows run, optimization problem is solved automatically and the fitting problem solves. So, but the main idea is that this is a run-ready workflow. Regular user doesn't need details to see how it works. Such user uses it just like an application, some specific problem-specific application. Well, let me go back and continue with the examples we added in this release. We also added the project which illustrates integration with emiSim. And this project solves the problem of single silent engine optimization, and its workflows contains both integration with Siemens NX and emiSim. There is one more example project we added. It shows this new algorithm of robust optimization technique. That's it, I think, about examples. And I will go back to the presentation. And finally, we proceed to Predictive Modeling Toolkit. Well, we came to the most interesting feature of this release. Actually, the ability to build approximation models was there since the day one, but in order to build a model, user had to construct the workflow with a model builder block. While it's quite straightforward, it was not convenient in the simple cases. And on the other hand, once model is built, user needs to somehow to validate it, to visualize it, and so on. And that's why we decided to develop Predictive Modeling Toolkit. And now it's in the latest pSeven version. In short, pSeven Predictive Modeling Toolkit allows to build approximation models with just a few clicks using the data gathered either from workflow execution or just loaded from CSV or Excel files. User may use smart selection while this model construction, which enabled by default, by the way, or user may tune approximation parameters if he knows what he's doing. Once model is built, Predictive Modeling Toolkit allows user to validate this model against test sample, visualize its internal validation results, or even compare multiple models to pick the best one. And user can use a model to predict values right in pSeven just by one click, or user may export this model as C code, as MATLAB code, or in some binary format to load it later in either in workflow or in another pSeven project. And now I'm going to show this functionality in action. I switch to pSeven again, close the project with examples, and open the project I prepared in advance for this demonstration. Basically, it's just another example project. So, to build the surrogate model, let me check my hints. Yes. To build the surrogate model, we of course need data. And this data can be gathered either from a project database or from some external CSV or Excel file. In this case, I won't take any data from project database, so I close it. And I will use some external file. For this, I import data from CSV. Sorry, I pick a wrong project. Just 1 second. I'm sorry. I'll take this one. Okay, again, I proceed to analyze screen, open report database, and import data from CSV. We could also load it from Excel file. By the way, to load from Excel file, we need to click here. Import data from Excel. Okay, I'm taking this test sample CSV, select it, check that CSV file parsed correctly. Here's preview. That's okay. And click import button. Here it is. Data is loaded into report database. Now I will select all this data and click this small button which named build model. Actually, this is a window into Predictive Modeling Toolkit. Here it is. This is a model builder dialog. There is an ability to, we need to specify, first we need to specify the model name. I don't like this long one. I will name it the model. This is the name of resultant model. The model, yes. Please note that there are 3 groups of options. And the select box which allows to select the approximation technique. In most cases, auto is the best choice, because in this case, smart selection will select the best technique and tune its parameter automatically. But if some user knows what he's doing, he can switch to, for instance, Gaussian processes or any other technique. Please note that there are three groups of options. Common options contains very simple options which is quite clear for any specialist, for any engineer. For example, user may specify if he needs accuracy evaluation function of the resulting model, or if user like this model be exact fit model, so it passes through all the points in the training set. For example, if user needs a linear model, he can switch this on this linearity required option, and so on. Quite simple and straightforward options. There is also a group of options which enables internal validation check, and there are some advanced settings for customization of this process. Actually, this is a kind of cross-validation technique. And also there are many other technique-specific options, but if you use auto, you simply don't need this. Okay, I specified the model name. First, I selected data. I specified the model name, and what I need to do, I need to select which of these data are inputs and which of these data series are outputs. For this, I switch and select these last three to be outputs. That's it. Now I simply click the build button and the model is building. You see that status is blinking here, which means that the model is training. Here it is. Since the data contains only 50, is built almost instantly. What can we do with this model now? Of course, we can check the details. I simply double-click on it, and I see the building options that what used. I see the training log from pSeven core or macros, if you'd like it. There is a training sample statistics, and there is also accuracy prediction if internal validation was enabled, and it was, since so you hear the accuracy predictions here, accuracy evaluation here. But what I'd like to do with this model then, I would like to check this model with on the training set, for instance, or on some external test sample. For this, I open Model Validator. It's another new thing in this release. I selected model, I selected some data. Let's imagine that it is a testing data, although it's training anyway. And I clicked this Model Validator button. Let me close this database. And here it is. This model validator allows to validate a model, definitely. There is an ability to plot scatter plot, which shows true values versus predicted values. And in this case, we validate this model on training sample. We can switch this into internal validation predictions, which were made during the training. And we can also validate this model against some external test sample, and this time it is the same the same as training one. You can see the year prediction in the bottom on this dialog. Actually, this is a different kind of metrics. The more interesting is to draw quantile plot, which shows which part of test points lie below some value of some year value. And the tooltip shows this quite clearly. Anyway, this is how we build model. This is how we visualize this model. That's not everything. That's not it. We also can make new predictions. For this, I select model again and click this Make Predictions button. I need to select input data series and specify the names of predicted outputs. Then click Predict button and the model will provide new results. What can we do with the model? We can also export this model to some external file, and at the moment you can export it as Octave or MATLAB script source for MATLAB, as a C source to make a standalone program, and as a C source to make a shared library, dynamic library from this model. Okay, let me show you more interesting example. I will switch to another report which I prepared in advance. And here it is. What I did there, I took some data from external file. You can see that there are 100 points in this data sample. I have created different models selecting techniques. The first one is created automatically. I didn't specify any options. And also I create four more models selecting different techniques and different settings. Now I'd like to compare these models. Since they all built on the same data, I'd like to check which one is better. For this, I will select all those models. Select the test data I'd like to use to check the models. And this time, this test data it's different from training data, of course. And I click Model Validator again. Then I close Report Database. And here it is. This Model Validator not only allows to show some years about a single model, it allows to compare models created with different techniques or even with different data sets. Again, I can draw a scatter plot which shows predicted values versus true values. For this, I will select a test sample I have provided, and I see that results, of course, different. So on training sample we have this picture, and on the test sample we have another one. But this says nothing about the quality of it doesn't help to pick the best model. To pick the best model, it's much better to switch to quantile plot, which clearly shows which model are better on this test sample. And as I already said, this model shows the plots which indicate the fraction of points which have a year below some value specified on this axis. So it's clearly seen that this blue model, green and red ones are bad, so I will disable them. Here is the list of all models shown on the screen, and I will turn off the blue model, which is constructed with GBRT technique. I will disable the green one, and I will also disable the red. Left, and as you can see, the model which was built using smart selections without specifying any additional options is the best one against all these. And this is also clearly seen on this table below, which shows different year metrics. We could also switch to internal validation predictions which were made during the training, and this is not very conclusive. But on external test sample, which is the most correct way to check the model, this auto model is definitely the best. So now I can pick this model, click it here, make new predictions, providing inputs, and so on. I can write this model out as a C code, I can use it in workflow, and so on. I think that's it about Predictive Modeling Toolkit for now. Let me check my slide. I've shown, yes, how to enable disable internal validation, advanced options. I have shown the model details, I show how to compare and validate different models, how to make predictions, and how to export models. I think that's it. That's it from me. So if you have any questions, please use chat. I will do my best to address all of them. You're welcome. By the way, visit us on our website. It's here on the screen. Connect with us through social networks. And there are actually a lot of interesting videos on our YouTube channel. So spend some time watching them. We're still waiting for questions. Maria, do we have any questions here? Okay, so if there is no any question, then feel free to contact us with the email on the screen. Feel free to contact me personally. There was my email on the first slide. And thank you for attention and have a nice day. Have a nice day. Goodbye.